Hello and welcome to your final challenge of Polygon Advanced. If you made it this far, definitely give yourself a pat on the back because you have certainly earned it. So what we're going to be covering in this video is the requirements for this project. We're also then going to look into how to create a simple custom circuit. This will help you to prepare for the more complicated custom circuit that you'll be expected to make for your project. And then lastly, we'll have a little bit of bonus material that you may find interesting. So we have a lot to cover, so let's just get right to it. So starting with the requirements, we can see we have a message here saying, imagine that you wake up, check your email, and you see an interesting task. Polygon has asked you to design a new circuit that implements some logical operations. You need to implement the circuit and deploy a verifier on-chain to verify proofs generated from this circuit. And you can see they included a circuit diagram here to give us an idea of how to structure this circuit. Now, if you're looking at this and you've never taken an electrical engineering course, then you're probably wondering what this is. So what you're seeing here in the top left, this gate, is called an AND gate. So how this works is if both A and B are true, then its output X will be true. However, if one of these is false, or if both of these are false, then its output is going to be false. So put simply, for this to be true, the output, both of the inputs have to be true. Now below this AND gate, you can see what's called a NOT gate. This is actually a pretty simple circuit, so whatever goes into it is flipped to the opposite. So if a 0 goes into this, its output will be a 1. If a 1 is put into this, its output will be a 0. Lastly here we have an OR gate. So for this output to be true, one of its inputs has to be true. So if X is true, then this will be true. If Y is true, this will be true. If both X and Y are true, this would also be true. However, if both of these are false, then its output would be false. Because again, one of those has to be true in order for this gate to return true. For this custom circuit, it's asking us to prove that we know the inputs of 0 and 1 yield a 0 output. So let's take a moment to see how that maps out, right? So A is 0 and B is 1. So we know this is an AND gate. And since 1 is true but 1 is false, then we know the AND gate is going to return a false output, which if we look at this line here, which shows an input of 0 and 1, we can see the output is a 0. Now B is a 1 and it's going into our NOT gate, so we know the output of that is going to be a 0. So if we look under the Y column, we can see that it is a 0. So we have a 0 here and a 0 here, which means that our final output would be a 0, as indicated here. And that's basically how you trace the inputs in a circuit. So that's a little crash course into what these are and how they work. Going into the tools that are going to be required for this project, we're going to be using the Hard Hat Circom repository. You'll recognize this as the one you used from lesson 4, which is this one here. And it's also offering a circuit library, which we will definitely be making use of. Now, as far as the requirements for this project, the first one is to write a correct implementation of the circuit, of course. The second will be to compile that circuit. The third step will be providing the desired inputs of 0 and 1. We will deploy the verifier to a testnet. Now here it says Goerli, but since Goerli now requires you to have Ethereum in order to get the testnet token, this is actually changed now to be either Sepolia or the Polygon Mumbai testnet. It's up to you which one you want to use, just so long as it's deployed to some testnet. And then lastly, we're going to call the verify proof method to verify that our circuit or output are working properly and it's providing that true statement. Submission requirements are the same for all the rest of your projects. So you'll have all your code inside of your GitHub. You'll have a README file, which I'm sure you are very familiar with at this point. If somehow you've made it here and you haven't done one of those, these are the template files for that. You'll create a general walkthrough video describing your code and what it does. Specifically, you'll be talking about how you put together your circuit. And then lastly, you'll be doing a demo of your circuit, just showing that it deploys to the testnet and the verifier is run and returns true. Then of course, these are where you deposit those links. So your GitHub goes here, your walkthrough video goes here. And then for the transaction ID, you can leave this blank if you want. But if you want to make the lives of the graders a little easier, when you deploy your contract, just put your contract address here so that it's easier for them to find that. So now we've gone through the requirements, let's talk about how we would create a simple custom circuit. So I've put together this beautiful circuit that you see here. What this is an AND gate joined to a NOT gate. So again, how this would work is if you imagine both of these inputs were true, they were both a 1, then this would output a 1, which would go into our NOT gate. Our NOT gate would turn that 1 into a 0, giving us a final output of 0, right? So this is what we're going to be designing. And so what we're going to do is get our tools, of course. So this is the repository that you used in lesson 4. If you already have it set up on your computer still, then there's no need to do this step. But if you don't have it on a computer or if you just want to start fresh, what you can do is go ahead and clone this to your VS Code. So we'll just do git clone and then the link that we just copied. So now we can see all the project files listed here. The next thing you'd want to do is either cd ZardKat to change into that folder. Or alternatively, you could do what I usually recommend, which is to go into File, Open Folder, and then just open that folder here. This way, everything by default is going to be set to that directory. So if you have to close your terminal, reopen new ones, it's always going to be in that directory. It just makes things a little easier. So now that we have it in our VS Code, we'll go ahead and see what the first instructions are here. So it tells us the first thing we should do is run npm I. That's going to install all of our dependencies. We'll go ahead and do that. Now, while that is getting all of our dependencies, if we look on the left, you can see that it says the next step is to run npx hardhat compile. This is actually not correct. Unfortunately, this is something that I can't correct on my own. So when you get to this step, what you'll actually want to do is npx hardhat circom, which we can actually do now. So we'll go ahead and type that in, npx hardhat circom. And if you do that, you'll see that it compiles the circuit successfully. We know that because it generates the verifier contract here, and it creates the output files here. And then finally, to deploy this, you just run the deploy command. Again, this is all the stuff you did in lesson 4, but just to verify that everything is working correctly, we'll just run everything on its default settings. So we can see it compiled the file successfully. It deployed it to this address on a temporary hard hat network. I ran the verifier, which returned true, and then it closed. So it looks like everything is working great, and we have a good foundation to start our coding. We'll go ahead and delete the out folder that the compiler created, and we'll delete the contract, as well as the artifacts and the cache folder. Otherwise, it can cause some errors if you try to run this again after customizing it a little bit. So here is our original circuit. We'll go ahead and delete the logic here. Now, I'm also going to change the name of this. You can leave it the same if you want, but I'm going to call it custom circuit. To make this a little easier, you can highlight it, right click, choose change all occurrences. And then when you do that, as you rename it, it's going to rename everything in that file that has that same text. So if we type in custom circuit, you can see that it changed it in both of those spots. Quite a time saver sometimes. The next thing that I'm going to want to do is change the name of the folder. Again, you don't have to do this because it does create some additional work that you have to do. But in case you do, this is the process for that. So we'll call this custom circuit as well. But now that you've changed the folder, there's 2 spots where you have to change the name to reflect this new name. The big one is right here in the circuit config file. So again, what you'll want to do is highlight the old name, right click, go to change all occurrences, and then we'll just type in the new folder name, which is not that. It is custom circuit. Go ahead and save the change. And then the other place is going to be the deploy script. So if we scroll down a little bit, oh, it looks like we're actually already there. But if you start at the top, you can go down to where you see the first instance of the old name. Go ahead and highlight that. Go to change all occurrences. And then just type in the new name like we did before. Save. And to verify, you can just scroll down and make sure that all the instances were changed. So it's changed here. And then the neat thing about this is it also changes it inside of strings. VS Code is pretty smart. It's very nice. Makes our lives a lot easier for sure. Okay, so now that that has all been changed, to just verify that everything still works, we'll go ahead and copy the old circuit code in here. Run the commands that we did before. And if everything runs successfully, then we were able to update all the names correctly, right? And excellent, so everything still works. Okay, so we'll go ahead and just delete all of that again. So we can go ahead and start creating our own circuit. And again, delete the artifacts and the cache. Out file. And the verifier contract. Okay. So one thing that we're going to want to do is start putting together our inputs. Now, to make things a little easier, I have some of this already put together. So we'll just copy and paste that in here. And now to make our life easier, what we're going to do is use this circuit library. So we'll go ahead and open this up. We'll go to circuits. And then if you scroll down to where it says gates, this will give you the template for all kinds of different logical gates. So we're going to be using the AND gate and the NOT gate. So we'll go ahead and copy these into our code. So we have our template and we have our template NOT gate. Go ahead and save that. And we'll close that since those are the only gates that we're going to be using. And so we know from our beautiful diagram, again, that our signal inputs are going to be A and B. So this is going to be signal input A, and then signal, spell it right, of course, signal input B. And now we're going to need the signal from our gates. In this case, we only have one gate, which is going to be this X. So go ahead and put that in, signal input X. And now we have to define what our final output of everything is, which in this case is going to be Y. We'll go ahead and put in signal output Y. So now that we have all of the inputs as shown in our diagram, the next thing that we're going to do is define our components. In this case, we have two components that we're using, right, which are the two gates that we brought over from the library. So what we're going to want to do then is bring those into our circuit. So we'll go ahead and do that. We'll call this component AND gate, and we're going to set that equal to whatever the name of the template is. So in this case, it is AND. And then we'll do the same thing for our NOT gate. So this is going to be NOT gate is equal to NOT. And so now comes the fun part of putting together all of the logic for our custom circuit. So since our circuit begins with the inputs, we'll follow those, and we can see that the first thing is our AND gate. So we'll go ahead and put that in first. If you want to do it another way, that's fine, as long as all your logic is correct in the end. But typically I like to start from the beginning and then just kind of work my way to the end. So we're going to have our inputs for the AND gate as shown here. So we can see that it has an input of A and B. So this will be AND gate dot A. And then what we want to do is put this signal input into the input for our AND gate. So we're going to use that operator, which is showing that our input A is going into this, right? Just kind of follow the direction of the arrow. And then we'll do the same thing for our next input. So AND gate dot B with a B going towards it. Then of course don't forget your semicolon. So now the last thing that we need to do is define our output, like where that output is going to go. So if we look at our AND gate, that's defined as out. So AND gate dot out. And so since this is leaving and going into something, we'll want to have what it's going into on the left side, which in this case is going to be signal input X. So we'll go ahead and put the X. And then the arrow just showing that that output is going to be stored into that signal input, right? So that's one circuit down now. And we'll go ahead and do the same thing for our NOT gate. If we look at our NOT gate, we have one input and one output. One has a title of in and then one out. So go ahead and type in NOT gate dot in. And looking at our diagram, we can see that the input of this NOT gate is going to be the output of the AND gate, which we defined as X. So we'll go ahead and put X into our NOT gate. And then we know the final output is going to be Y. So we'll go ahead and put Y, then NOT gate dot out, just providing that final output, right? And believe it or not, that is it. Like our whole circuit is now done, right? Because we have our signal inputs A and B going into our AND gate here, doing the calculation, outputting that to our X. That X is going into our NOT gate here, doing the computation, and then providing the final output of Y as shown in our diagram. So we'll go ahead and compile our circuit. And if all goes well, oh, seems like it has not. So we'll go ahead and take a look and see where we went wrong. Okay. So it looks like I accidentally put this as an input. Now, if you're wondering why that's wrong, inputs that are coming from outside the circuit are called signal input. But if it's an internal input, like this X is here, where it's coming from inside the circuit, then it's only called a signal. But then this one is called signal output because it's leaving the circuit, right? It's going to the exterior, which is why we have this output here. So just so you understand why that came up the way it did. So we'll go ahead and run this again. Oh my gosh. So what did we do? Okay, so we forgot our semicolons. You know, even when you're programming for a long time, you still make really simple mistakes sometimes. So just goes to show even I am human. These are these are common things that you'll come across as a developer yourself. So now we have our semicolons there. We have everything named correctly. Everything should now compile. And thankfully it does. We can see that that's true because now we have our output files here. And we can see that we have our custom circuit verifier now. So then the last thing that we need to do is deploy our circuit. And I typed this previously, so I'm just being a little lazy here and going back to it. So it compiled successfully. We can see that the circuit deployed to the hard hat network here, and it returned true. So we have together successfully taken this circuit, programmed it here, successfully deployed it onto our local hard hat network, ran the verifier, and everything is working as it should. So now seeing how to create this custom circuit, it should give you a better idea now of how to create the one for your project. So you can see like you have your signal inputs here. You have a signal here, a signal Y, a signal X, and then a signal output of Q. And then you got your gates. So we load those as your components here. And then just wire them just like we did here, right? So just follow your diagram. You know, the A's and B's go to your AND gate. You've got a B that's going into your NOT. You've got X and Y that is going into your OR gate. providing a final output of Q. Okay? So now that we have done that, as a bonus, what I'm going to show you now is how to deploy something like this to a test network. I recognize that some of you, this may be new for you, so I believe this will help with that final requirement, right? So if you're coming into this and you have no idea how to do something like this, as a developer, obviously you're the person that typically has to come up with the solution. And your best friend as a developer is Google. So if you were coming into this not knowing how to make RardKat deploy onto one of these networks, what you would do is search something like this, like RardKat network deploy. And if you ran that search, we can see that RardKat has some instructions already for deploying to a live network. So we'll go ahead and click that. And if we scroll down, we can see instructions for deploying to a remote network, which is what we're going to be doing. So here it's showing a key. We're not going to be needing something like that because we're just going to use a public RPC. But if you were using a private RPC, then you would need to provide the key for that. So what we really need is this right here, where it's showing how to set up your config for that external network. Since this is a Polygon course, I'm going to use the Polygon Mumbai network. But first things first, what we'll do is copy that. We'll go into our RardKat config. And we can see that we can basically just put this anywhere under Solidity. So we'll just go ahead and paste that here. And then of course we want to include that curly brace. And then a comma, since we still have something following it. So now we have to configure the URL. So now if you were trying to figure out how to find a public RPC, you would do a search query like this, right? You would search for Mumbai public RPC, which brings you to the following listings. Chain list is pretty nice because it'll give you a list of like every single RPC that's available, as well as the latency times of those RPCs. Now, one that I like to use is this anchor one. You can use any of them that are on this list. I'm just using this as a personal preference, my own. And then what you'd want to do is paste that in for the URL. Okay, cool. So step one, done. We have our RPC. But since we're deploying onto a live network, that's going to cost currency, right? In this case, since it's the Polygon network, what we're going to need is MATIC. And we're also going to need a private key of a wallet that's going to pay this MATIC, right? So now I've set up a what you call a burner wallet, which you can see here. It has no MATIC, absolutely nothing on it. So if you wanted to get the private key for this, what you would want to do is click into here and go to account details. And then you have this show private key option. But here's the thing, right? So when you are pasting sensitive information like this into your code, if you did your video and you were going through this, or if you upload this to your GitHub where other people can see it, now everyone would have access to your private key, right? And we know that's bad because if they have access to your private key, that means they can steal everything that's on that account, right? So as a developer, you would not want to do this, obviously. So instead, what you would want to use is something called a environmental variable. So these are variables that your code can use so that none of the private variable information is contained within your actual code, right? So you can upload this to your GitHub, you can share it with people, and they won't have that variable file. So what they would have to do is create their own private variable file in order to run the code. So to show you how that works, the first thing that you'd want to do is import something called .env. So you do npm install .env. And that's going to install all the dependencies for this. But of course, we're getting a little ahead of ourselves. So if you were trying to figure out how to set up a .env, you would do a Google search just like this, right? Setting up .env. We see we have a couple different results here. I like this one from npm. And if you look here, it tells you exactly how to install it, the commands you have to run. And then you can see in order to use it, we have to create a .env file in the root of our project. So we'll go ahead and do that. We'll call this .env. And then in this file is where you would store the variables and the private information, right? So here we'll just call this Mumbai private key. Set it up like that. And for now, we'll just leave it as it is. So now we can go ahead and get that private key. So again, we go to our burner wallet. We click into account details. We click show private key. And then what you'll want to do is type in your password. Once you do that, it will show you the private key for your account. So now once it's here, you go ahead and copy it. And then we'll go back to our file, paste it in, and save it. So now we have our private key stored here in this file. And when you go to upload this, you can see in your git ignore, by default, it ignores environmental variables. So when you upload this, it will ignore this and not upload it, so that this file will only exist on your computer. So now that we have that set up, let's go and see what the rest of our instructions say to do. So it says the last thing that we need to do is import .env into our project file. So since we're using that in our hard hat file, we'll go ahead and click into that. We'll go to the top and we'll use this command here. And we'll go ahead and save that. And then the last thing that we need to do is just change this to use our environmental variable. Here you can see an example of what that would look like. So you have to do process.env dot whatever you named your variable. So we'll go ahead and do that. So process.env dot by private key. So then that'll put that into here for use in our account. So then the last thing that we need to do is actually put MATIC into this account so that we can pay for the deployment fee. And again, if you weren't sure how to do that, what you'd want to do is search for Mumbai Faucet on Google. To save some time, I'm just going right to it. And then it'll load up your wallet. Get the public address of your wallet. Then what you do is go ahead and paste your public key here. You'll click Send Me MATIC. And then you can see Let's just close that. Here you can see the transaction for that deposit. And if we actually go back to our wallet, we can now see that we have one MATIC. So excellent. So going back to our code, so let's take a look at this. So we have our URL, we have our account key to pay for the fees. One thing that we'll do is just change this to Mumbai for consistency's sake, and I believe we are good to go. So we'll go ahead now and deploy to the network. And we're getting a message saying that the Mumbai network doesn't exist. So let's see where we went wrong. Okay, so when I copied this, I forgot the actual network thing here. So all we then have to do is follow that convention, right? So just networks and then curly braces, and then we just paste that inside and we should be good. So now if we go ahead and run it now, everything should work correctly. This is a problem when you're coding things live, but oh, it looks like success. So it deployed to this contract address. It came up true. So let's go ahead and actually look at this transaction. Now we are using the Mumbai testnet, so we'll go ahead and select that, paste this in, and see what we have. So we had a contract created 53 seconds ago. This was our verifier contract. If you click into the transaction, this is the contract that was created. This is the wallet that we use to pay the fees and everything. We can see that it cost this much. And if we look at our wallet, we can see that it was deducted here. It's not showing an activity for whatever reason, but we can clearly see that it was deducted. And with that, I believe we have covered everything. So we covered how to create a custom circuit. We covered how to deploy it onto a live network, how to use a faucet. And with that, you should be 100% ready for this challenge. I hope all of this was informative. I apologize that it's such a long video, but with so much to cover, it's kind of hard to condense it without losing really important information. I wish you luck with your final project. I know you're going to kill it, and I will see you on the flip side.